Okay, in this video we're going to be looking at the graphs of some polynomial functions, and we're going to be coming up with the equations or the formulas for those functions based on the graphs. So in example 1 you've got these three graphs of polynomial functions, and it says identify the zeros or the roots and the factors of the following polynomials. So the first thing I notice for each one of these graphs is that each one of them represents a fourth degree polynomial. And I know that because this one, it has 1, 2, 3 bumps, which means 3 bumps, and it must be a fourth degree polynomial, which means it's going to have 4 roots or 4 zeros. Same thing for this one. I've got 1, 2, 3 bumps, which means it's a fourth degree polynomial. It's going to have 4 roots. This one is maybe a little bit harder to see, but this also has 3 bumps. 1, 2, 3. These are not quite as pronounced because I've got this flattening here going on, but I've got 1, 2, 3 bumps, which means this is also a fourth degree polynomial, and I'm going to have 4 roots here as well. So let's write down the roots for each one of these graphs. So my roots here are going to be it's going to be the points where it crosses or touches the x-axis. So I've got a root here at x equals -2. I've got a root at x equals 0. I've got a root at x equals +2. And I've got a root at x equals 4. And let's see over here, I've got a root at x equals -2. And I also noticed that here at -2, I've got a bounce. And that's a good thing because otherwise I would only have 1, 2, 3 roots because this only crosses or touches the x-axis at 3 points. But since I've got a bounce here, and I remember that a bounce means that the root at that bounce point is repeated an even number of times. So I'm going to have 1, 2, and then a double root here at x equals -2. So let me write that one down twice. I've got a root at x equals 0, and I've got a root at x equals 3. And for this one, my roots. All right, now in this one, it looks like, at first glance, it looks like I've only got 2 roots because it only crosses here and here. But once again, I remember that since I've got this flattened area on my graph right here, and anytime I've got a flattened area at one of my roots, that means I've got a root that is repeated an odd number of times. So this root is going to be repeated a total of 3 times, which means I've got 3 roots here and 1 here for my total of 4 roots. So this root is at x equals -2. This one is at x equals +2, and since that's a triple root, I'll write that one down 3 times. Okay, so here's all of my roots for each one of my graphs. Now, since I know that for each one of my roots, I also have a corresponding factor. Let me go ahead and write my factors down. And the way we write down the factors is if we kind of think of our roots, the way I've written the roots down here, x equals -2, x equals 2, x equals 4. If you think of that as an equation, and you want to get everything onto the left side of the equation so that the right side can be equal to 0, well, if I add 2 to both sides of my equation, then that will give me x plus 2 on this side and 0 on this side. And that's my factor. X plus 2 is going to be my factor that corresponds to this 0. X equals 0, well, here I've already got everything on the left side and 0 on the right side. X equals 2, if I subtract 2 from both sides, that's going to give me x minus 2 equals 0. And for this one, if I subtract 4 from both sides, that gives me x minus 4. So here are my 4 factors for this graph of my polynomial function. And since I have these 4 factors, I can go ahead and write down the equation for this graph in what we're going to be calling factored form. So here are my 4 factors, and I just write them down. X plus 2 is a factor times x minus 2 times x minus 4. And now I have a formula for this polynomial function in factored form. Let's go ahead and do that for these other 2 as well. I've got my roots. I want to write down my corresponding factors. So x minus 2, let's see if I add 2 to both sides, that's going to give me x plus 2 equals 0. X plus 2 equals 0, that's my double root. Here I've already got x equal to 0, that's going to be my factor. And here if I subtract 3 from both sides, that gives me x minus 3 equals 0. Here are my 4 factors for this function. So I can write down my formula for this function. I've got my 4 factors, x plus 2 times x plus 2 times x minus 3. And here I can write down my 4 factors as well. Let's see, add 2 to both sides. That gives me x plus 2. This gives me x minus 2, x minus 2, and x minus 2. And once again, I can write down my equation using my factors that correspond to each one of my roots. So y equals x plus 2 times x minus 2 times x minus 2 times x minus 2. Now, it turns out that for each of these 3 graphs, these equations that I've written down here, these formulas, these actually are the formulas that correspond to each of these graphs. However, often we have graphs in which we have to do this additional step in order to get the final formula for that graph, and we're going to take a look at one of those right now. So the factored form of a polynomial equation looks like this. A times x minus r1 times x minus r2 times x minus r3, and so on, depending on how many zeros your function happens to have. Now, up to now, we haven't really dealt with this letter A that I've put on the front here. We've just dealt with x minus r1, x minus r2, x minus r3, where the r's are the roots, or zeros if you prefer, of your function. Well, it turns out there's also another piece of the factored form of an equation for a polynomial function, and that's this a piece. The a is just a constant, and very often we have to figure out what that constant is so that we have the complete form of the complete factored form of our polynomial function. Let's take a look at that. Here we've got example number 2. It says find a formula for this polynomial. And for this polynomial, let me put in my marks there. So for this polynomial, I can see that I've got 2 bumps. And since I've got 2 bumps, that means that I've got a 3rd degree function, which means I've got 3 roots, or 3 zeros. And in fact, I can see where those zeros are. One's right here. It looks like there's only one right here, but I see I have a bounce right there, and so there I know that that's going to be a double root. So I can go ahead and write down what my roots are for this equation. I can write down my 3 roots. So my roots are going to be, here's one at x equals -1. And I've got this one at 1, 2, 3 at x equals 3. And since there's a bounce there, that's a double root. So I've got x equal 3 repeated an even number of times, 2 times. And there's my 3 roots. Now I can also write down the factors that correspond to these 3 roots by moving everything over to the left side of each of these equations. So this is going to give me x plus 1. This is going to give me x minus 3. And that's also x minus 3. So here are my 3 factors that correspond to my 3 roots. Well, I can use these factors now and write down, plug these into my factored form here. And I'm going to go ahead and include the a here as well. So my factored form, what I've got so far for the equation for this graph is y equals a times x plus 1, that's my first factor, times x minus 3, that's my second factor, times another x minus 3, which is my third factor. Now, notice I have everything I need in my formula except I don't know what the value of a is. Well, in order to figure out what the value of a is, what I need is I need another point given to me on the graph of my equation. And in fact, I have that. If you'll notice on your set of notes, it's maybe a little bit easier to see, but you can see that the graph crosses this point right here, which is the point 0, -3. So I have a point on my on the graph. I have another point that I know will solve this equation. Well, since this point right here, the point 0, -3, this is an x coordinate, this is a y coordinate, I can take this point and I can plug it in to this incomplete formula that I have, and I can then solve for a. So let's take a look at what that's going to look like. Here's my point, x equals 0, y equals -3. Let me plug in the 0 and the -3 for my x's and y's in this equation. So my y value is -3. I'm going to substitute that in here. My x value is 0, so everywhere I've got an x, I'm going to plug in this 0. X equals 0, x equals 0. Well, now what I have is I have an equation, and I have one unknown, a. I'm looking for the value of a. That's the only unknown in this equation, so I should be able to solve this equation. So let's see here. -3 equals a times 0 plus 1 is 1. 0 minus 3 is -3. 0 minus 3 is -3. -3 equals a times, so let's see. 1 times -3 is -3. -3 times -3 is +9. So this is a times 9. Now if I divide both sides of my equation by 9, my 9's cancel out here, and I'm going to be left with a equals -3 over 9, and if I reduce that, I get a equals -1/3. Well, now I know what my value for a is, and now I can write down my complete formula for this graph. Let me write it over here. Y equals a, which is -1/3, times each one of my factors. X plus 1 times x minus 3 times x minus 3. And now I have the complete formula for this graph of a polynomial function. Now, one other characteristic, I guess you could say two other characteristics of polynomial functions are what we call maximum and minimum values. Now, polynomials can have a relative maximum or a relative minimum, which just means a maximum or a minimum value within a certain range of x values. Polynomials may also have what we call an absolute maximum or an absolute minimum, and that just means a maximum or a minimum that is a maximum value for the entire polynomial. That is a maximum value that's a maximum for the entire range of x values, the entire domain. So example number 2, it says sketch a graph of the function h of x and identify any maximum or minimum value. So if you take this polynomial function here and if you plug it into your graphing calculator, then you will get a graph that looks something like this. And this point right here is -2, and this point right here is 3. So I can see that I've got a 4th degree polynomial. I've got 3 bumps, and I've got 1, 2, 3. Well, I would have 3 zeros. I've got a double 0 here, so I've got my 4 zeros. It asks me to identify any maximum or minimum values. So the maximum or minimum values, this value right here, this point, notice that the graph comes down to this kind of low point and then goes back up. That means what I have here is a minimum value on my function, but it's only a minimum value within a fairly limited range of values. That is, it's only a minimum value, say, between here and here. That's called a relative minimum. So I've got a relative minimum at this point right here. Notice right here I've got a maximum, that is, my graph goes up to this maximum point here and then goes back down. But this is Again, it's only a maximum value within a relatively narrow range of values. So this I would call a relative maximum. And you can notice, like right over here, for example, here's a point that is greater than the value of this point right here. So this is not an absolute maximum, it's just a relative maximum. It's a maximum point just in this small range right here. Now, here's another point right here where notice the graph comes down to this kind of low point and then goes back up. Well, this is a minimum point as well, but notice that this is actually the minimum point. This is the lowest point in the graph for the entire graph. That is, the graph starts over here and it comes down, goes up again, and then comes back down, and then goes up again. Well, it never gets, since the graph never gets any lower than this point right here, this is what we call an absolute minimum. So for this particular graph, I have 3 maximum minimum points. I've got a relative minimum here, I've got an absolute minimum here, and I've got a relative maximum here. And now, as we're going to look at a little bit more in class, you can also use your graphing calculator to determine the actual value of these points here, the actual x values and y values of these points. You can use your graphing calculator to tell you those. And we're going to take a look at those a little bit more in class tomorrow.